Hey everyone, welcome to my channel. So in this video I'm going to try to solve this problem. At the same time, I'm going to follow the general interview steps while trying to solve this problem. So let's get started. First of all, we need to have a good understanding about what the question is asking us to do. Let's read through this question. So given a n by n binary matrix, return the length of the longest line of the consecutive ones within the matrix. So the line could be horizontal, vertical, diagonal, or anti-diagonal. So let's see. There are some constraints here. So it's a n by n matrix. So the matrix is gonna be a binary matrix for sure, which means each of the cells is either 0 or 1. And for the matrix is never gonna be empty. The number of the row or column is anywhere between 1 to 10k, and the matrix contains anywhere between 1 to 10k cells. So for this first example, we have the return value as 3 because this diagonal line is going to be the line that contains most consecutive ones, and we have 3 consecutive ones on this diagonal. Here, this one we return 4 because we have 4 consecutive ones on the first row. So having read the problem, I don't see any clear edge case here, so let's directly jump into the second step, which is about finding approach. So how are we going to solve this problem in general? The first solution I can think about is, I would say it's pretty intuitive idea, is we could go through each of the line. So for example, take the example of the row. We are going to go do one pass through this row. When we do one pass through this row, we need to keep 2 things. One is the time counter. So the time counter indicates the number of consecutive ones we have that ends with a 1 at the current place. So we are going to have a temporary counter. At the same time, we are going to have a global variable which is called max counter. So once the time counter is larger than max counter, we need to reset max counter to be time counter. So let's say how we are going to update the max counter and time counter when we do one pass of the first row. Suppose we start time counter at 0, max counter at 0. Of course, when we are at the first place, we don't need to update the time counter because currently it is a 0. So we have 0 consecutive ones with 0 consecutive ones that comes before or at the current place of the cell we are currently looking at. And when we are at the second cell, we are going to increase the time counter by 1 and reset the max counter to be 1. Then when we are here, it's another 1, and we are going to increase the time counter to be 2. And then update the max counter. When we are at the last cell of the first row, we see this is a 0. Then we are just going to reset the time counter at 0. So that's pretty much how we are going to go through each of the line. And it's pretty much the same for all the vertical lines or diagonal or anti-diagonal lines. It's just the x and y's, the indices of the corresponding cell, how we are going to, it's just going to be the index of the x and y. Otherwise, it's pretty much the same. So having said that, the runtime is going to be O n by n. So this is an n by n solution for the runtime. Space-wise, it's going to be constant because we only need to keep the time counter and max counter and also the x and y's. So having said that, I think by now this is the best approach I can think about, because we definitely need to visit each of the cell. Otherwise, we are going to miss some information here. So if we do at least one pass through each of the cell, then at least the runtime is going to be, the big O analysis is going to be O n by n. So having said that, I would say this would be the best approach I can think of regarding the runtime and the space. And let's do some coding work on top of it. So we are going to go through each of the row. So for go through each row, in this part we are going to go through each row. like I said, we need to have a global variable which is called a max counter. Let's initialize as 0. And for the readability, we could keep the row count as mat.length and the column count as equal to mat.0 at 0.length. This is pretty much how many rows and columns we have within this matrix. Then we are going to go through each of the row here. So as equal to 0, I smaller than row count, and the plus plus I. Here we are going to have a time counter as equal to 0. And we go through each of the and we do one pass through each of the row. J, we use J to indicate the column number for each of the row. So J is smaller than the column count plus J. So I would say if the time counter is, if the current cell is a 0, then we are just going to reset the time counter. Otherwise, we may potentially need to update the max counter depending on the value of the time counter. This would be something like if the matrix, if mat ij is equal to 0, then we are going to set time counter as equal to 0, and then we continue. Otherwise, we are going to need it will be something like max counter is equal to max of max counter or plus time counter. So yeah, so that's it. I'm thinking about if we could make this piece to be shorter. Max time counter. Okay, so time counter, no, so I think that we can leave it later. And then we need to do something similar for each of the column. Go through each of the column. It would be pretty much the same. So I would just copy paste the code. So instead here, it's gonna be J from 0 to column count. And then we go through every row at the corresponding column. This would be something like row, and yeah, and we don't need to change anything around here. So right, okay. So this is for each of the column, and then that's the diagonal or anti-diagonal stuff. So so as we could see, we have m plus n diagonal or anti-diagonal. So this part you would say goes through each anti or just diagonal. Here, let's say we could see the index as equal to from 0 to row count plus column count minus 1. Okay, so plus index. It's from 0 to row plus column minus 1. That's the number of the diagonal or anti-diagonals. So the first thing we need to make sure is the start I and start j, because for diagonal, once the start I and start j is confirmed, we just need to plus we do plus 1 on top of each of the row or column count or column index. If it's anti-diagonal, we just plus 1 on the so for example, we just plus 1 on the column number, and then we minus 1. So here we do plus 1 on the row number and do minus 1 on the column number. So what we need to do is we just need to make sure about the start place here. Let's say we are going to let's say this is diagonal count as equal to 0. So this is pretty much the same as time counter. This indicates how many consecutive ones do we have for the diagonal, and then we are going to have another one for anti-diagonal. Alright, so we initialize the counter here. It's just the next thing for us to do is to confirm the start I and start j. So we would say, okay, start I, it's going to be, so for here, if the index is something, so if the current index is something smaller than m minus 1, then it's gonna be decreasing. Okay, so I think I know something about it. So it will be something like this will be something like, is the index larger than or equal to m minus 1? If the answer is yes, then we are going to, so if the answer is yes, then the I is, which is the row number, is going to be 0. Otherwise, it will be something like m minus 1 minus index. So this is a start I, and then we have the start j. So when I say start I and start j, and we go through the index, for the diagonal is going to be like this way, which means this is the first diagonal we are going to visit. So for this one, let's confirm the logic. So start I is going to be m minus 1 minus 0, which is going to be okay. Okay, so the next one is to confirm the start j. It's the same thing. If index is larger or equal to m minus 1, then the start column is gonna be index minus m plus 1, which means index minus m. Okay, so index minus m plus 1. Otherwise, it's gonna be 0. Okay, so let's see for this one. For the first diagonal, the start j is going to be 0, and when it comes to, when the index is equal to m plus 1, then it's gonna be 0 again. When it is m, then the start j is going to be 1. Okay, so I think it should be good. And then what we need to do is we just need to, so I say I is equal to start I, and j is equal to start j, and every time we just plus I and plus j, I plus j. The thing we need to make sure is we don't go over the range. So we need to make sure that I is smaller than row count and j is smaller than column count. And okay, so if matrix, so this part is the same. If ij is equal to 0, then we okay, so let's just keep just one thing. We just keep one time counter. So time counter is gonna be 0 if the current cell has a value at 0. Otherwise, we are going to update the time counter and also potentially reset the max counter. Alright, this is for each of the diagonal, and we also need to do the same thing or similar thing for the anti-diagonal. So you have the time counter set as 0 here. You need to compute the start I and start j. So this is start j. So for start I, let's treat this one as the first anti-diagonal we are going to do, and this like in this way. Here, this first one, second one, third one, something like this. So one, I would say, if the index is larger or equal to, okay, so I'm using some m, but m should actually be row count. Row count. Okay. And it should be here. If it is larger than the column count -1, then we are looking at it to be index minus column count +1. Otherwise, we are looking at just the index itself. All right. And for the start, okay, so this should be the start. No, this should be start j. And for the start I, we are looking, so for the start I, it should be, well, okay, so if the start, okay, so if it is larger than that, well, let's see. So for the start j, which is a column count, if it's larger than or equal to the column count -1, which means we are actually here, then it should be, okay, it should be column, well, if it's, okay, so if it is smaller than the column count, then it should be the index. Otherwise, it should be just column count -1, which is the last column. If the, okay, so that's, I think that's the start j. And for the start I, which is the column count, it should be from 0 to, okay, so when it is, okay, so if index is smaller than the column count, then it should be always 0. Otherwise, we should start somewhere as index minus the column count +1. Okay, alright, so I think now we have the start I and start j, and we need to do the same thing here. Okay, so now we have all the things, and then finally you're going to return the max counter. Okay, so okay, we need to update the logic here, because here we need to, this is plus plus, this is plus I plus j, that's correct, but here it should be this should be plus j, but this should be plus I but minus j, minus j, because we are going this way, which means plus the row number and minus the column number. And here we need to make sure that j is larger or equal to 0. Alright, so I think we should be okay. So I will rely on this platform to help me to do the debugging work. Okay, as it says, we have something expected. Okay, so some syntax stuff. This is okay. This is about redefinition. Alright, so the first one got accepted. Let's see some other examples. Okay, so two of them is correct. Let's do a summation on top of it. Alright, so we are good with this approach, and that's pretty much it about this video. So if you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.